Okay. Distance. Distance is simply length. Yes. So we are trying to get a single number. Let's go to 2 dimensions. If you have 2 points in the on the 2D plane, x1, y1, and x2, y2, what is the distance between those 2 points?
We have to use the distance formula.
Distance formula, which is
Square root of x2 minus x1 squared plus y2 minus y1 squared.
yes. If you have 3 points, let's say, oh, sorry, if you have a 3D space, in that case, you have x1, y1, z1, and x2, y2, z2, call it d2. What would the distance between those 2 points be?
The same thing, just with the
Same thing, but you will add
this
an
is it.
additional coordinate. So it's just an extension, and from here you can go to the 4th dimension, 5th, 6th, and we just keep on going. You just add additional coordinates. Here is an example using distance. What does equidistant mean?
Point, a specific point that is an equal distant from both of the points given.
So you pick an arbitrary point, and the distance between 1 minus 1, 2 and that point must equal the distance between 2 minus 1, 1 and that point. So I'm going to call the arbitrary point I'll call it ABC. There is a reason why I'm using ABC. Then I'll use NBC, then CBS. None of you have kids. Okay. How would we go about doing this?
I was thinking midpoint formula.
Midpoint formula, okay. I mean, if we're simply looking at, horizontal, vertical, midpoint would be right in the middle, equidistant. But if you put it in a different angle, midpoint's not going to work, right?
If you don't have a different angle, it's technically on the 2D plane.
A 2D point.
Well, it's on the y doesn't change, so you can visualize it in a 2-dimensional space.
So if you look at the y, it's just at -1. So you are looking at a plane. Yes. So you just want to, I erased it. You just want to find the distance between 2 points on that plane because it's at -1. But what if you had something else instead of -1? Let's say you had 16.
Could you use the distance formula and divide by 2?
Very good. I forgot it.
Here,
Hey, eventually I remember. I was thinking Angela for some reason. I don't know why. Does your last name start with A?
yes,
That's right. Distance formula. If I find the distance between that and that, I can set it equal to those two. Right? The distance, they have to be the same. So A minus 1 squared plus B minus of -1 plus 1 squared, C minus 2 squared. Yes? So that point and that point must equal A minus 2 squared, B plus 1 squared, C minus 1 squared. Does it matter, whether I do A minus 1 or 1 minus A? Doesn't, because that's the point. Just make sure the coordinates align. I want you to simplify this. Let's fully simplify. In other words, you FOIL and simplify. You will get an equation. I'd like to know what that equation is. One term definitely will get cancelled. I'll go back to, starts with C, Carter. No. What do you mean?
Chase.
It's close. Next time. I'll just visualize him as a walking credit card, then I'll remember the change. One term is going to go away based on what Chase said. Which is that term?
The B plus 1
The
squared.
B plus 1, because that is the y coordinate that's going to disappear, so that will go away. And you would have A squared and C squared. So I would like to know what that equation is, which contains A squared, C squared, and lambda constant 2. I was too quick to conclude that you would see A squared and C squared. My bad. Those will get cancelled. We'll simply have a term in A and term in C. So you don't have to carry this forward, the root, this and that, they just have to equal each other. So I can write A minus 1 squared, B plus 1 squared, C minus 2 squared equals A minus 2 squared, B plus 1 squared, C minus 1 squared. That's the Haley's suggestion of equating distances. One of the terms would go away, okay? B, because you are restricting, or restricting y to be -1. Those would simply get cancelled. How would we go about simplifying this? If you leave it as is, it's not very clear. Agreed? We don't know what that equation is. If you FOIL, what would that equal to? A minus 1 squared.
A squared minus 2A plus 1.
Agreed. How about that?
C squared minus 4A plus 4, or 4C, sorry, plus 4. I did the same thing when I wrote it.
Same on this side, a squared minus 8a plus 4,
-4.
that, and c squared minus 2c plus 1. A squared will get cancelled. The 4 will get cancelled, 4s. 1s go away, c squared goes away. Let's move all the a's and the c's. So 4a minus 2a minus 2c would become plus 2c minus 4c equals 0. 4a minus 2a is 2a. 2c minus 4c, negative 2c. Yes, I'll simply have a minus c equals 0. Now, you look at that and you want to visualize what comes to your mind. I mean, you got rid of y because we are referring to the same point. Yes,
Would it be a linear line from the x and z axis?
Haley, say, would it be a line? Now, equidistant from that point, will it simply lie on a line in 3D space? We're shaking,
Maybe
watching it.
Conic
Corner, okay,
would be a plane.
will be a plane, right? Because if it is 2D, we can say it's a line, but it's not in 2D space, rather it is in 3D, so it will be a plane. What plane is it? Well, it is a plane where A is equal to C. We still can't visualize. A is my x coordinate, B is the y coordinate, C is the z coordinate. So x is equal to z. This is where Haley got the straight line aspect. This, if you fix at the origin, it is a line that will go through the origin between the axes, x is equal to z. But that's not the case. Here, we are letting y run.